Okay, today we'll see about the image formation by a convex mirror. Image formation. It will be image formation by a convex mirror. This will be our topic for today. But before we actually go into today's topic, I would just like to take you through what we had done in the previous video. We had done about image formation by a concave mirror, right? Image formation by a concave mirror. And if you remember, it formed 5 plus 1 images. 5 plus 1 images. Now you may be wondering, what is this 5 plus 1 images? I told you there were 5 real images, right? 5 real images and 1 virtual image. 5 plus 1. Now if I have a, let's say, if I have a concave mirror here, right? My various positions, let's say this is F and this is C. So if you have gone through the previous video, you will find that there is one object at infinity. This object is at infinity, right? The position of this object is at infinity. And you know that if the object is at infinity, the image is formed where? The image is formed at focus, right? The image is formed at focus. Then from there, we moved to behind C. If the object is kept behind C, the ray of light, okay, the ray of light travels what? The ray of light travels parallel to the principal axis, and after refraction passes through the focus, you can take another ray of light passing through the focus, and then you find the image is formed where? The image is formed between C and F. This was one. Then after this, right, after this we moved on from C, from behind C we moved on to C, right? If the object is kept at C, this is F. If the object is kept at C, the ray of light travels parallel and passes through the focus. Once again, the ray of light passes through the focus and the image is formed. Actually, the image is supposed to form where? The image is supposed to formed at C. And then we moved on where? Then we moved on between C and F, right? This was the next position. See, I can say position 1, position 2, position 3, position 4, and then the object was at position 5, and then the object was at position 6. When the object was at position C, if you remember, the image was formed where? The image was formed if the object was at position 6, right? At position 6, the image was formed behind, and this was what? And this was the virtual image, right? This was the virtual image. I'm just giving you, or I'm just taking you through, roughly taking you through of what we had done in the previous class. Okay, so with this in mind, we move on to what? We move on to the next topic, and the next topic is image formed by a convex mirror. Now we move on to the next portion, and that is sign convention for reflection by spherical mirrors. Sign convention for reflection by spherical mirrors. Now you may be wondering, sign convention, signs, right? Sign, there's a positive, negative signs, okay? Convention for reflection by spherical mirror. This is a very important, this is another very important topic. Now you may be asking why this topic is important, because in the chapter of light you will have numerical problems, okay? Numerical problems, physics, you definitely need to do numerical problems. Now you will be able to do all numerical problems in light only if you will be able to do all numerical problems correctly in light only if you have a good knowledge about the sign convention, right? So we will see about this topic, the sign convention, and find out where are we supposed to use positive and in what situation are we supposed to use negative. Because once you are thorough with this topic, you will have no problem in solving the numerical problems of physics, and in the final exam, of the past experiences that I have seen, there is always a problem for 3 marks, the numerical problem of light for 3 marks in the final exam. Okay, so let's go to it. Now, in order to understand the sign convention, let me draw a concave mirror, right? Please keep in mind, this convention is true for concave mirror or convex mirror. This is the painted surface. You know that concave mirror is a spherical mirror in which the reflecting surface is bending inwards, right? So now this is the geometrical midpoint, so this is the pole, right? Pole, this point is what? This point is what we call it as the pole, and therefore I draw, sorry I missed it, anyway, okay, pole. This is the principal axis. So I have the focus and I have the center of curvature. Let's say I keep an object here, right? And this is the pole and this is the object. The distance between the object and the mirror is, let's say, 10 centimeter. What is the distance? 10 centimeter. Now, if you measure from here to here is also 10, right? And if you measure from here to here is also 10. Distance is 10, right? Now you may be wondering why I'm giving you this example. It's because when you measure from here to here, it's 10, of course. And when you measure from this point to this point is 10, of course. But there is a problem. If you measure from here to here, it will be positive. If you're measuring in this direction, right? Positive. But if you're measuring in this direction, it will be negative. Now, let me make it more clear. Remember that the incident ray of light always travels from the left to right. This is the incident ray, okay? This is the incident ray of light. It is traveling always from left to right. Now, the first thing in case of sign convention is all distances are measured from the pole. Please keep in mind, all distances are measured from the pole. You can't measure from anywhere. For measuring any distances in any distance in case of spherical mirror, you'll find that you have to start from the pole. So if you are measuring a distance, let's say if you are measuring from pole and if you are coming in this direction, right? In this direction, because you can see here, you are supposed to measure from the pole. Now, you please understand that the incident ray is moving in this direction, right? The incident ray is moving in this direction and you are moving in this. That means both of them are in opposite direction. Both of them are in opposite direction, okay? So all distances measured from the pole, the first point, okay? All distances, right? All distances measured from the pole will be what? Will be negative, and that is what you'll see. Okay, all distances parallel to the principal axis are measured from the pole of the mirror. That's point. That's point one. All distances measured to the right of the origin along x-axis are taken as positive, while those measured to the left of the origin along negative x-axis are taken as negative. That means, according to textbook, if I am to use the language of the textbook and explain this, you'll find that this point, the pole becomes the origin. Let me extend it. Okay, so you know that even in graph, if this is the origin and this is the x-axis, right, x dash, this is the origin, all distances measured here is going to be what? Is going to be positive. Everything measured from pole towards this side, towards the right side, will be positive. And you know that in x-axis this is negative, right? So all distances measured from the pole towards the left side is going to be what? Negative. Very, very important. Once again, to simplify this, this is the pole, this is the pole. If the distances are measured in this direction, that means if they are measured on the negative x-axis, it will be negative. If they are measured on the positive x-axis, it will be positive, right? Keep in mind. Then next is distances measured perpendicular to and above the principal axis along the y-axis are taken as positive. If the distance is measured above the principal axis, right? If the distance measured above the principal axis, these are all going to be what? Positive. Above the principal axis, this is going to be positive. All distances measured above the principal axis is positive, and all distance measured below the principal axis is going to be negative. All distance measured below the principal axis is going to be negative, right? This is another point. So I think for all of you, please keep in mind that when it comes to sign convention, point one, all distances are measured from the pole. If you are, this is the incident ray, okay? If you are measuring against the direction of the incident ray, right? You know, incident ray is traveling like this. If you are measuring against the incident ray, it's negative. If you are measuring in the same direction as the incident ray, it will be taken as what? Positive. All distances measured above the principal axis is positive. All distances measured below the principal axis is negative. So these are the 2 points that you need to keep in mind where for sign convention. Now, in case of mirror, object distance, right? Object distance. Please keep in mind, object distance is represented by small u, right? Image distance, right? Image distance is represented by v, okay? Focal length, right? Focal length is represented by f. Very important. And the mirror formula is 1 by v plus 1 by u is equal to 1 by f. This is mirror formula. We'll be using this formula when we do the numerical problems. Now, in order to clarify the spherical sign convention, let me give you an example. Let's say this object is at a distance of, this is the pole, right? Pole, and this object is at a distance of 10 centimeter, right? So if I ask you the question, how much is u? U. How much is u, or what is the value of u? Okay, what is the value of u? U, you know that u is object distance. So if I ask you what is the value of u, I have told you that the object is kept at a distance of 10 centimeter from the mirror. So what is u? Whether u is plus 10 centimeter or whether u is minus 10 centimeter. If you tell me that it is plus 10, that means wrong. If you are telling plus 10, that means you are measuring from the object to the pole. That is a wrong way of doing it. Your answer should be what? Minus 10. Why minus 10? Because distances are measured from the pole, right? Distances are measured from the pole, and you are moving in this direction. You are moving towards the negative of the x-axis from the origin, right? From the origin. So if you are moving in this direction, this is the direction of the incident ray, and if you are moving in this direction against the incident ray, your u is going to be what? This is going to be -10. Okay, let's say the height of the object, this is the object, the height of the object is 2 centimeters. So whether it will be +2 or -2, +2 or -2, +2 or -2. So those of you who are telling -2, it will be wrong, because the answer is +2. All distances measured above the principal axis, okay, all distances measured above the principal axis will be what? Will be positive. Let's say the image is formed here. So let's say, and the height of the image is 1 centimeter. So whether it will be +1 or -1, the answer should be what? The answer should be -1. Why? Because all distances measured below the principal axis is negative, right? Okay, uh, just adding to this one more. For example, let us assume that the image is formed here. Okay, the image is formed here. So, and the image formed is at a distance of 5 centimeter from the mirror. So whether this image distance v will be +5 or -5. Understood? This is the origin, this is the direction of the incident ray. If you are measuring in the same direction as the incident ray, this should be what? This should be plus. Okay, once again, if you are measuring from the pole and against the direction of incident ray, then it is going to be negative. If you are measuring above the principal axis, positive. If you are measuring in the same direction as the incident ray, it is going to be positive. If you are measuring below the principal axis, it's going to be negative. Okay, magnification in case of mirror. Magnification, see, magnification produced by a spherical mirror gives the relative extent to which the image of an object is magnified with respect to the object size. What do you understand? Magnification actually gives you an idea of whether the image formed is larger than the object or is smaller than the object. Magnification, in short, is only a comparison between the size of the object and the size of the image, to find out whether the image formed is larger than the object or smaller than the object. Okay, and magnification m, right? M is represented by what? M is height of the image, right? It is height of the image, that is h dash by height of the object, right? Height of the object h. So I can write this as m is equal to h dash by h, right? This is one magnification. And magnification is also what? Magnification m is also related to the object distance u and the image distance v. It can be expressed as m is equal to minus v by u. Magnification is also the ratio of object distance, right? Object distance to what? Object distance to image distance, right? Image distance, object distance is magnification, object distance u and image distance, right? Sorry, this should be sorry, I made a mistake here. So it's actually the image distance, right? Is actually the image distance to the object distance. And image distance is represented by letter v, and object distance is represented by letter u. Object is always negative, so this will be minus. So you can write m is equal to minus v by u. So in case of magnification for spherical mirrors, right? In case of magnification for spherical mirrors, m is height of the object, height of the image to the height of the object, or image distance to the object distance. Okay, with this we have come to the end of the mirror section of the chapter of light. After this we have the numerical problems, but numerical problems we will be doing at the end of the chapter. Now just revising or going back to what we have done so far. we started with the chapter of reflection, right? In the chapter, we started with the topic of reflection of light. What is reflection of light? When a ray of light travels from one medium to another, when it's traveling from one medium and then it strikes a reflecting surface, it bounces back into the same medium, and that is reflection. Laws of reflection. Uh, Laws of reflection. We dealt about law of reflection. The angle of incidence is equal to angle of reflection, and the incident ray, the reflected ray, and the normal to the point of incidence all lie in the same plane. Then we moved on to this plane mirror. Plane mirror, you know that the image formed by a plane mirror is of the same size as the object. The lateral inversion, right? Equal distance of the image and the object from the mirror. After which we move on to the spherical mirrors, and today we have discussed about the image formation. So please go through this topic carefully before we move on to the next topic, and in the next section of this chapter we'll be dealing with lenses, right? And especially spherical lenses. Thank you.